So we're going to start talking a little bit about, we're going back to our digital fabrication and education continuum. Our first field activity was for kids, and we saw some great examples. And now we're moving along the continuum. There are a lot of different things we can do with kids in the digital fabrication kind of continuum, whether they're just designing or they're designing, building, testing, iterating, redesigning, building, test-rating, researching all themselves. So we're moving along the continuum with this process, and we're going to start this next field activity will be something that you do with your kids rather than for your kids. Next slide. So thinking about what we did during our last field activity, and we're going to talk a little bit about what the differences between where we were and what we're doing next. So when we're working with 4 kids, the lesson plan is also often centered around, it should be centered around non-learning objectives. And of course, the teachers do the design and fabrication. Essentially, digital fabrication for kids is adding a custom teaching aid in a lesson plan. So things that you don't really have to worry about when you're doing this for their kids is really safety considerations aren't really needed for the machines. The students' technological literacy, their experience with digital fabrication processes and machines is not really relevant because they're not putting their hands on the tools for that. And then typically you can integrate these into easily into class time. So it's like adding a physical teaching aid to a lesson plan that can be done in your class time. Those are the basics. So moving to the next one where we're talking about digital fabrication with kids, you'll see that there are some key differences in how you're going to put these lesson plans together. Again, let's talk about the lesson plan being centered around non-technical learning objectives, but with using technology, really that technical learning can also be embedded in the lesson. Depending on what you're teaching and what you're using to teach it, your students will need to learn a little bit about technology and digital fabrication. And those learning objectives can be included in your lesson plans. So the design and or fabrication processes are included in the lesson itself. And this is up to you as a teacher where your comfort level is. And where your students' comfort level is. Really thinking about the students' technological literacy and experience with digital fabrication machines in this stage is very relevant. Do your students know how to do the simple things on the computer, or will you be having to spend some time with them just learning how to navigate websites or download files or upload files? So really understanding where your students are coming from as far as their digital literacy, specifically with the processes that you're going to be using with them is important. And that will take a little bit, unless your school has a framework or a scaffolded extension for where your students should be in their technological literacy, which I have run into very few schools that have this kind of framework. Then as a teacher, you will probably need to figure out where your students are technologically in their literacy. And then also what's really, really important is the teacher experience and comfort level with the digital fabrication machines that they'll be using in the lesson. Sometimes this teacher experience and comfort level can be mitigated if you have a technology consultant or somebody who works in the fab lab or has more technological experience to co-teach. It's a good way to think about that. We'll talk about this kind of concept of co-teaching and a little bit more in module 3, but I think pointing out the differences in what the teacher needs to know to run a lesson like this and what the students need to know in a lesson like this is pretty important. The other thing to think about when you're using digital fabrication with kids is just safety. So what are your safety precautions that are happening with the tools? Go ahead, next. So what I notice that teachers tend to fall into sometimes, especially when they're doing a making project with their students, is switching from lesson plan mode to project plan mode. And what we're really trying to focus on here in Fab Learning Academy is the lesson plan mode. So there are some differences between what are we doing? Are we making a project plan? Or are we making a lesson plan? And let's talk about this, because when you see them on scopes, you can see project plans and you can see lesson plans. And it would be just a good idea to kind of go over what the expectations are and what the differences are between making a lesson plan versus making a project plan. So in a project plan, the objectives are pretty much product based. You'll see people write things like students will design and build a blank. And so that's really focusing on the product of the plan. And then a lesson plan, the objectives are more learning based, like students will be able to identify the planets in order of the solar system. So if you see, just the phrasing of those two objectives are completely different, even though they might be doing the same thing. In the lesson plan, the students might also be designing and building a model of the solar system. That's not a learning objective. They're learning about the solar system, and this is part of the lesson plan. So in a project, when you're making a project plan, the making activity pretty much constitutes the entire plan. But when you're making a lesson plan, the making activity is just one aspect of the lesson plan. And often more time is spent on other sections of the lesson as well. So thinking about videos, books, articles, presentations, other things that are connected to the content, to the learning objective is centered in lesson plans, as well as the fun and exciting making project that we're talking about. And then, so when you look at a project plan versus a lesson plan and a project plan, you'll see the steps are really about following the steps to make the product or the project again. Step one, open up Tinkercad. Step two, have the students sign in. Those types of steps are very, you can follow and create a project. And everyone will kind of come up with the same project after the project plan. But in a lesson plan, you can also have steps for kids to follow technology-wise. But the overall plan itself will include a lot more steps that don't necessarily have to do with the making project itself. So maybe the first step is introduced into the lesson content with an exciting and engaging video. And then step two might be, do a parent share activity where the kids talk about what they already know about the planets. And so those steps are really more about the learning. And then embedded in those steps is going to be kind of a project plan. So what we're looking to push everybody towards is really thinking about the lesson plan as far as what we're learning, and using the digital fabrication project as a step, as a tool in that lesson plan. It will be the most fun step, by the way. They'll love it. Okay, go to the next one. So thinking ahead to our module 2 field activity, I just wanted to put this up so that you guys can start thinking about what you'll be doing. You'll be designing a digital fabrication lesson with kids. It should be centered around non-technical learning objectives, but also can have technical learning objectives embedded in the lesson. Digital design and or fabrication processes are included in the lesson itself. How are students going to interact with the machines? And that can be up to you, really. Safety considerations that you'll have to consider, and students' as I said before, students' technological literacy, and often more time is needed for these types of lessons. And of course, your experience as a teacher is kind of important. So go to the next slide. Let's talk a little bit about framing your learning objectives around your curriculum or your standards or your subject area. So when you're designing lesson plans with digital fabrication, you really need to know your learning objectives. But you can see that what's really cool about digital making, if you look at this Venn diagram, is there are all these different learning concepts. We've got our subject area learning. We've got our technology learning area. We've got kind of our soft skills. Those are all things that students are learning when they're working within the digital fabrication continuum. You have to teach, a lot of teachers have to teach subject area learning. They have requirements, and some schools actually also have requirements for technology learning. So it's really whatever your school or your district is requiring for you to embed. I've met a few schools who have kind of soft skills or social emotional learning competencies, or 21st century skills, or sometimes we call them STEM competencies, those types of skills that can be embedded in well. So really thinking about your activity in the middle of all three of those learning objectives. So teachers can design these digital fabrication activities and include all three of these types of learning objectives. You can go to the next one. So let's talk a little bit about where those original learning objectives comes from. Do they come from standards? Do they come from your curriculum? Whatever that requirement is for you as a teacher to teach, those are what we'll start talking about as standards. I know that here in the States, we use the term standards, and I know in a lot of other countries you have a national curriculum. So when I use the term standard, I also mean national curriculum, basically the requirements, what you're required to teach to your students. And this slide shows some very interesting standards that not everybody is required to use. But what's kind of cool about the digital fabrication making is your students can learn a whole lot of stuff beyond what you're required to teach. And also for those teachers that don't have a required standards or a required curriculum to follow, aligning your lesson plans with standards or with a national curriculum is still important, because what are these kids learning? And especially for your, administrators or your principals, showing that your students are not just, 3D printing a model of the science of the planets, but they're also, learning these objectives. So I shared on this slide, and actually they'll be on the website as well, links to all of these different types of standards that you can use. You can browse through them. Some of them are really excellent. Some of them are less standards and more open objectives. Like if you haven't checked out the Fab I Can statements, they're on scopes.org. They're an interesting list of objectives or outcomes, really, that the students should be able to do. And they all start with I can or students can. So you can check them out too if you want, Ivana. I don't have access to my computer right now. But the Fab I Can statements is, especially if you don't have standards to base your lesson on, can be something that you can use in your classroom. Yeah, I can't, I'm looking at this on my phone right now, so I can't really see them. But you'll see that the Fab I Can statements are separated into like 5 things, I think: design, computer programming. What's the next one? Electronics, modeling,
fabrication.
Yeah.
And
there might be one more. Safety. Yeah. So especially if you're starting, if you're like a technology or a STEAM teacher and you don't really have standards to follow, I would look at these and start to think about how your students can work through these. These are pretty broad, but you can use them for your own lessons. And really that's why we kind of came up with them when we were working on scopes. Otherwise, the standards, whatever standards or curriculum that you're working with. So then let's talk a little bit about the curriculum or the standards versus the learning objectives, because what you're required to teach usually comes in a very wordy and descriptive and vague kind of format, but what your students will be doing should be pretty specific. So looking at the differences between what a standard would say versus what your learning objective would say are pretty important. So the purpose and scope of a standard is really broad, and it's really about the long-term overarching content mastery. And then the learning objectives should be short and specific and for each lesson. So the specificity, the standards are usually less specific, and the learning objectives should be measurable, actually clear and measurable for what students are learning. And then the alignment with the greater curriculum. Standards are really, that's the whole point kind of standards and national curriculums, is to align across grades, really, from K to 12, where are students supposed to be. And as far as learning objectives, that really should align with what the lesson activity is and what the expected outcomes are of the lesson activity. And then the assessment standards are often assessed over time, and they are often high stakes. For instance, here in the States, in different states in in America, we'll have pretty much high stakes testing, and I know that teachers across the globe have this challenge as well. The important test that everyone takes, and everyone needs to pass in order to graduate. They're kind of high stakes assessment tests. And when you're assessing a lesson plan or your learning objectives, the assessment should be within the lesson itself. What have the kids learned about the lesson that you're teaching? So it's really lesson learning objectives can be assessed right then and there, and you don't have to kind of wait until your state or your national test. Okay, next. And then so here are some examples of the differences between suggested differences between, say, a standard versus a learning objective. And the standards that I shared here are the common, these are all American standards. Common Core math content is a standard. And you can see apply properties of operations as strategies to add and subtract. That's quite vague if you're going to have your students learn that. So translating it into a learning objective, and piecing it out into what they're actually doing. They'll be able to solve addition problems within 10 by using counters or drawings. So that's a pretty straightforward activity or a measurable outcome that you can have from your lesson. The other one is next generation science, and then computer science standards. So these are just examples to demonstrate the difference between what you're doing in your lesson versus this. I mean, to support the standard that you're teaching towards.